Okay, so over the next few videos, we're going to talk about quadratic equations, and which are things that have x squareds in them. We're going to move on to talking about cubic equations where we've x cubed, and then talk about equations where we could have an x to the power of 4, an x to the power of 5, or 6, or 7, and so on. But before we delve too deeply into the new material, I need to be sure you're 100% clear on the junior cert material. So in this video, I'm going to talk to you about quadratics only. But we are going to look at a few things that you won't have come across before. Just imagine this one. If I told you if a quadratic curve has roots of -2 and 6, write the quadratic as an equation in the form ax squared plus bx plus c equals 0. I'm going to do this by two separate methods. The first one here you should be familiar with. The second one you won't have seen before. So if I have a quadratic curve and I know the roots, I can form the quadratic in the form, I can write the quadratic in the form ax squared plus bx plus c. And it's relatively straightforward to do so. Roots should be written in the form x equals -2 and x equals 6. However, in this question, I haven't given it to you in that form because often in an exam question, they just write it like that to try and throw you off. Roots, whenever you're dealing with roots, you should write them like that. Remember that roots are the points where the curve crosses the x-axis. If x is equal to -2 or x is equal to 6, then if I know the roots, I can turn them into factors. In order to turn a root into a factor, you simply move the number to the side that the x is on. So in this one, I could add 2 to both sides, and I could write this as x plus 2 equals 0. In this one, I could subtract 6 from both sides and write it as x minus 6 equals 0. So what I have on the first line are what are referred to as roots. What I have on the second line are what are referred to as factors. It is vitally important you understand the distinction between the way we're writing them. Factors are the numbers that the terms I can multiply by each other to give me the original equation. For example, the factors of 12 are 3. An example of factors of 12 are 3 and 4. If I multiplied those two factors by each other, I would get 12. 3 by 4 gives me 12. So if the factors of a quadratic are x plus 2 and x minus 6, in order to form the quadratic, you simply multiply them by each other. I could multiply x plus 2 by x minus 6, and that will give me the quadratic. So this is just double brackets. You multiply the first thing in the first bracket by the second bracket. You multiply the second thing in the first bracket by the second bracket. And if you multiplied it out, in this case you would get x squared minus 4x minus 12 equals 0. So that's something that I do with my junior certs. If you're given the roots, it should be relatively easy for you to form the quadratic. However, there is another way of doing exactly that I want to look at. I just want you to, before I do it, I want you to be aware that in the leaving cert, the way that if you're given roots and you want to form the quadratic, you should do it like this. But I'm going to show you another way of doing it because it's going to come into play when we look at complex numbers when we're further into the course. Okay, so let's say we're just going to take the exact same question again. We've been told the roots of a quadratic are x equals -2 and x equals 6. Every single quadratic equation can be written in the form x squared minus x multiplied by the sum of the roots plus the product of the roots. Every quadratic can be written like that. So let's just have a look at this. Sum means you add them together, product means you multiply them by each other. So I could rewrite this quadratic. The question told me the roots of the quadratic are -2 and 6. So the sum means you add them together. So x squared minus x times the sum in this case would be -2 plus 6. -2 plus 6 is simply 4. So it would be x squared minus x times 4 plus the product of the roots. The product means you multiply them by each other. -2 multiplied by 6 gives me -12 equals 0. Obviously here I could rewrite this as x squared minus 4x minus 12 equals 0. So that's another way. I want you to take that down and highlight it in your notes. I always advise my students not to use this in algebra. So when you get to complex numbers further into the course, you'll be given roots, complex roots, and you'll use this to generate quadratics. I usually tell students you're better off to use the first method I did where you convert your roots into factors and you multiply them by each other and you get your quadratic. Either way, both is perfectly acceptable. Okay, so we've worked out two ways of generating a quadratic when given the roots. But I also want to think about if you know the roots of a quadratic and you know the quadratic, you know the actual quadratic in the form x squared plus x plus a number, you've a load of information about how to sketch the quadratic. So I want to talk about, just with this information, how could I sketch a quadratic? If I have a plus x squared, I know that it's a U-shape. And if the roots are -2 and 6, then I know it crosses the x-axis at -2 and at 6. So I'm just drawing a rough sketch here. I know it's a U-shaped graph, and because it's an x to the power of 2, it has one turning point. We're going to develop this, and we're going to be talking about x to the power of 3's. If you have an x to the power of 3, it's called a cubic, and it is 2 turning points. If you have an x to the power of 4, then it has 3 turning points, and so on. So an x to the power of 2 is the one that we mainly talk about at junior cert, and it has one turning point. It's either a U shape if it's a plus x squared, or it's an N shape if it's a minus x squared. And a quadratic tends to have two roots. In this case, x equals -2 or x equals 6. But I also want to point out to you the relevance of the constant at the end. Remember from junior cert that the constant at the end tells you the y-intercept. I know that the points where it crosses the x-axis would be -2, 0 and 6, 0. But if there's a -12 here, that also tells me that it crosses the y-axis at 0, -12. So in this video, that's all I want to explore. I want to explore, given the roots of a quadratic, generating the actual quadratic in this form, and then we're going to sketch a few quadratics as well. Okay, so let's explore that material now. The first one I have here says a quadratic curve has roots x equals 3 and x equals -4. I want you to write the quadratic curve in the form ax squared plus bx plus c. I want you to use both methods. I want you to try it twice, use both of the methods I showed you at the start of this video. And then I want you to sketch the curve detailing where it crosses the x-axis and where it crosses the y-axis. In question 2, now this one is a bit different that I think you're going to be able to figure out yourself. It says a quadratic curve has roots x equals 2 and x equals -1 and crosses the y-axis at 0, -6. I want you to write the quadratic curve in the form ax squared plus bx plus c equals 0. Now this one you're going to struggle with. This one is different, so I want you to see if you can figure it out. If it crosses the y-axis at -6, that's where the problem is going to lie. When you have it written in this form, I then want you to sketch the curve. In fact, sketching the curve at the very start might help. You should sketch a curve, I'd say first, sketch a curve at the very start might help you to figure out question 2. I want you to pause the video, try these two questions, and then compare it to my solutions. Okay, in question 1, I told you a quadratic curve has roots x equals 3 and x equals -4. In order to generate the quadratic, you can turn x equals 3, you move the 3 to the other side, and you get x minus 3 equals 0. In this case, you add 4 to both sides, and you get x plus 4 equals 0. Now you've got your two factors. Once you have the two factors, you simply multiply them by each other, and it gives you the quadratic x squared plus 1x minus 12 equals 0. That's one way of doing it, but let's have a look at the other way of doing it as well. The alternative way of doing that is to use the formula that every quadratic can be written in the form x squared minus x times the sum of the roots plus the product of the roots. The sum means you add them together, so 3 minus 4, if I add them together I get -1. The product means you multiply them, so 3 times -4 gives me -12. And then minus x times -1 gives me +1, and then I just write this as -12. Notice I get the same answer that way as I do when I get the factors. My advice to you is, for the vast majority of cases, you should use the first way that I did it. You turn them into factors and you multiply them by each other, just because it'll make it easier for you to do the more complicated stuff we do in a couple of videos' time. And then you need to be aware that if you know x equals 3 and x equals -4 are the roots, that refers to the points where it crosses the x-axis. If it's a plus x squared, then that means it's a U-shape. And if there's a -12 at the end when it's written in this form, that indicates that it crosses the y-axis at the point 0, -12. So that's all that we need to look at for part 1. Now let's have a look at part 2. And in part 2, you were asked to sketch the curve. To sketch the curve, I just wanted you to come up with something like this. It has roots x equals 3 and x equals -4, which indicates that it crosses the x-axis at 3 and -4. It's a plus x squared, which indicates it's a U-shape, and the number at the end, or the constant at the end when it's in this form, is a -12, which indicates it crosses the y-axis, at 0, -12. Let's have a look at question 2 now. It says a quadratic curve has roots x equals 2 and x equals minus 1 and crosses the y-axis at 0, minus 6. The first part of this question asks you to write the quadratic curve in the form ax squared plus bx plus c equals 0. So we can treat this exactly the same as question 1. If I know the two roots, I can convert the roots into factors. So if x equals 2 is a root, I can convert that into a factor and say that x minus 2 is the factor. If x equals minus 1 is a root, convert it into a factor of x plus 1. And if I multiply the factors by each other, I'll generate the quadratic. So the quadratic I generate from these roots is x squared minus x minus 2. And you'll notice that I've drawn a little sketch of it here. It has roots of minus 1 and of 2, and it crosses the x-axis or the y-axis at minus 2. So up until this point, that's all that you've really seen. However, there are an infinite number of quadratics that have roots x equals 2 and x equals minus 1. And this one has these two roots, but it crosses the x-axis at minus 6. So that means that the graph I'm actually looking for, it crosses the y-axis much lower down. But it crosses the x-axis at the same point, so it's much steeper. I could still sketch myself a curve that crosses at minus 1, crosses at 2, and crosses the y-axis at minus 6. If it's steeper, I simply need to figure out what do I need to multiply this constant at the end by so that it will become a minus 6. I need to multiply it by 3. So I need to multiply everything by 3. If I multiply everything by 3, the quadratic that has roots x equals 2 and x equals minus 1 and crosses the y-axis at 0, minus 6 is in fact 3x squared minus 3x minus 6 equals 0. If I had given you this and asked you to factorize and solve it, the very first thing you would do is you would divide everything by 3 and you'd have x squared minus x minus 2 equals 0. You'd factorize and solve it and you get the same two roots. You'd get x equals 2 and x equals minus 1. Now, I just want you to be aware that we're going to do an entire video dedicated to that kind of thing later on in a couple of videos' time, where there are actually an infinite number of quadratics that have roots of x equals 2 and x equals minus 1. Another way that I could have complicated that question is I could have, instead of saying 0, minus 6, I could have said 0, 6. I could have said it crosses the y-axis at 0, 6. And if that had been the case, that would have meant that you actually need to change the sign of this as well. You would have had to multiply minus 2 by minus 3 to convert this into a plus 6. You would have ended up with a minus x squared, so your graph would have turned into an N shape. But for the moment, I just want to briefly mention that, and we're going to come to it again when we delve further into algebra. Now, I already alluded to part 2 in the first part of the question, but nonetheless, we should draw ourselves a nice sketch. I know that the quadratic can be written in the form 3x squared minus 3x minus 6 equals 0. It's still a plus x squared, so it's still a U shape. I know its roots are 2 and minus 1, so it crosses the x-axis at 2 and minus 1, and I know that the y-intercept is down here at the point 0, minus 6. So that's what was required to answer part 2 of the question.